yesterday's quiz.
Look, alright.
You don't have to look at it yesterday's quiz.
Everybody failed yesterday's quiz, okay?
I got like 2 out of.
You already graded it? Did you grade it already?
The quiz yesterday? No,
Yeah.
I can see it's the future. I got like a 2 out of 17.
I have not graded the quiz yesterday. That was yesterday. I graded like a few of them. The ones that I did really well.
Yeah, fine.
I don't, off the top of my head, I don't remember who I graded, but I grabbed the first couple and I had a couple minutes and did it. They did well. I mean, the only if they missed something, it was like, you know, 1 point, 1 out of the 3 points here or there, but mostly good. The ones I've seen.
Yeah.
Okay. Okay, so bivariate data now. We're looking at what's called bivariate data. So bi meaning two variate data. So we're comparing two things. On yesterday's quiz, you looked at, what was it? Weights of first class letters. And then another one was was ages, right? Median ages or IQR ages. Now what we're going to be doing is we're going to be comparing two things versus each other. How do they compare versus each other? Okay, that's why it's called bivariate data. Okay, so describing those relationships. Okay, that's what chapter 3 is all about. So what are we comparing? Well, we're comparing an explanatory variable and a response variable. Okay, response variable is the outcome. What happens? What is the outcome of what? Of the explanatory. Something is introduced, it causes a reaction. How do you measure it? That's the response. The whatever is being introduced is called the explanatory variable. Okay, so if we were to graph them, explanatory would be X, response would be Y. Okay, so explanatory is something that's introduced that's made to see if there's what's happened. What is the outcome of it happening? Okay, so it may help or explain or influence change in a response variable. What happened is Y. Okay. Okay, so let's look at the first set of data. The first set of data is a scatter plot. So we're going to make a scatter plot. We're going to make a scatter plot in a second. But first, what are the two variables that we're measuring? Body weight, backpack weight. They both happen to be pounds. They don't have to both be the same. Like it's a coincidence that they're both in pounds. You could compare two things that aren't the same in terms of their units of measure. Okay, but in both cases are weight. Okay, so we have a body weight and we have a backpack weight. So what they did was they measured a person. How much did they weigh? Like the first person right here, 120 pounds. That's how much they weighed. And then they weighed their backpack. How much does their backpack weigh at that moment? 26 pounds. Okay, the next person weighed more, 187 pounds. Their backpack weighed a little bit more, 30 pounds, and so on and so forth, right? That's what they did. So it's 1, 2, 3, 4, 5, 6, 7, 8 students. I'm guessing they're students since they had backpacks, but they could not be. Okay, 8 people. So we're trying to see if there's a relationship between a person's body weight and a person's backpack weight. Is there a relationship? That's why we do this. Okay. So when we make a scatter plot, we're going to make one by hand, and then I'm going to teach you how to do it on the calculator in a second. Okay, so when we do a scatter plot, we need an X and a Y. So the first thing we're going to do is we're going to plot an X. Oops, I don't want that. We need a Y axis and an X axis, right? Okay, because we're comparing two things. Now I got to know, so this one's going to be X and this is going to be Y, just like normal. So label and scale your axes. Well, before I can label, I got to know which one's X and which one's Y. So which one do you think is going to be the explanatory or X? And which one do you think is going to be the Y, which is the response? Body weight's X, yeah. And there's a couple reasons why it gives it away. So let's put X in here and Y in here. Now, the most common reason why, oh, body weight is X. So those of you that say body weight is X, what makes you say that that's going to be the X value? What makes you think that? Good, yeah. It's going to determine, we're trying to see how much it's going to, backpack's going to weigh. That's actually the right answer. The wrong answer, or not necessarily, I don't want to call it a wrong answer, but the answer that kind of gets sometimes confused is some people say, well, X comes before Y in the alphabet, right? So isn't the top one going to be X first? Not necessarily. Not necessarily. I've seen them where they're flipped. Okay. Sometimes they'll tell you which one's X, which one's Y. Sometimes you kind of look at it and be like, okay, what are they trying to do here? Well, they're trying to see if a person's body weight has any effect on how much their backpack weighs. Okay. Okay, so now we got a label. Body weight down here, since that's the X. Backpack weight, since that's the Y. Okay. Scale now. So the scale for body goes from 109 or 103 to 187. 103 to 187. So I'm probably not going to start with 10, 20, 30. I'm not going to do that because then I won't have my first dot till way over here, right? So what I'm going to do is I'm going to kind of, what you can do is you can count ahead, which sometimes you'll see this, sometimes you'll see one of these. It looks like a heartbeat monitor thing. Sometimes if you've seen that, that means they counted ahead. And they started not at 0. They started at 0, but then they sped up. So we start at 103. So I'm going to say this is 100. And then I'm going to count by 20s after that. Okay. Backpack weight isn't as high, but still it starts with 24. So we're going to need to speed up again as well. So this one we can, so we're going to put another one of these guys here. And then we can start at, go 20. Well, they only go up to 35. So maybe we count by 2s. 30, 32, 34, 36, 38. That's about it, right? The highest is 35. What does it start? Does it start at 24? Yes, that was supposed to be 20. Thought I was, when I was counting, I was like, why does it end so quickly? Because I started at the wrong number. So it should be 20, 22, 24, 26, 28, 30, 32. I think that's as high as I need. Oh no, 35, I got a 35. 34, 36. Now, is this the only, do you have to label by 20s on the X? Do you have to label by 2s on the Y? No, you can label by 5s. You want to label by 5s, 20, 25, 30, 35, that's fine too. If you want to label by 10s down here, that's fine too. Okay, this is just what I chose. Okay. Scatterplot. Scatterplots are plots that are scattered. So we just make dots. Plot individual data values. So the first one, the first person is 120 pounds and they weigh, and their backpack weighs 26. So 120 pounds, 26. The next is 187 and 30. $109 and 26. $103 and 24. Let's see, 131, 29, 165 and 35. 158 and 31. And 116 and 28. So you should have 8 dots when you're done. So if you've scaled it correctly, and if you put the dots correctly, you should get a picture. So what do you look for when you're looking at a scatter plot? You're looking at a couple things. The first thing is, as I'm getting bigger in body weight, so as I go to the right, as I'm getting bigger people that weigh more, what's happening? What trend is happening? What's tending to happen to backpack weight? It looks like it's increasing, right? It looks like as I'm going this way, as if I start at this dot over here and I move this way, it looks like the dots are kind of going up, right? Not all of them. This guy over here, guy or girl, I don't know whose it is, but that one we would expect to be a little higher, right? So it's not perfect. It's not perfect data. It's raw data. Raw data is not perfect. Okay. So maybe if this guy was a little bit higher, it would be a little more. But overall, it looks like as body weight gets bigger, so as backpack weight. Does that make sense? Does it make sense that as someone weighs more, that their backpack is going to weigh more as well? It makes sense logically, right? But anyone who goes to school knows that's not always the case, right? Sometimes people who don't weigh as much have a lot of books and their backpack weighs a lot, right? Just because they don't weigh as much, right? And then I have when I taught Math 1, when I used to teach Math 1, I would have some students, some big guys, and it didn't look like there was a piece of paper in their backpack. It looked like, honestly, there was nothing in their backpack. I don't even know why they carried a backpack, right? So it just, but it kind of makes logical sense that as you weigh more, you can carry more, right? So it makes logical sense, but that's why it's not like, if it was perfect, if it was like a fact, the more you weigh, the more your backpack's going to weigh, all the dots would have lined up in perfect line, like right, all on that line, something like that. But they didn't, right? So, but we can say that they tend, as your weight increases, your backpack tends to increase as well, backpack weight. Okay. So how do we describe what's going on? We kind of did describe it, but there's 3 big things you got to hit when you're describing what's going on: relationship or association. So sometimes it'll be called association. Sometimes it'll be called relationship. Sometimes it's called correlation. Any of those, if they're say, describe the association, describe the relationship, describe the correlation, these are the 3 things you need to hit. Strength. Is it a weak relationship, association, correlation? Is it moderate, not really strong, not really weak, kind of in the middle? Or is it strong, very strong? Oh yeah, everyone who weighs more has a heavy backpack, and everyone who weighs less has a lighter backpack. Okay. Form. Now here's the thing. In this class, we only worry about linear. So don't worry about non-linear. We don't cover any non-linear relationships. We only cover linear. So form is always going to be linear. And then which way is it going? Is it going positive or negative? So how do we tell? Yeah, how do we tell if it's going positive or negative? Up or down, right? Up or down. If it's going up, positive. If it's going down, it's a negative. Okay, so now let's go back and look at the one we just did. What would be the direction here? The dots are kind of going up, right? as I move this way, they're kind of climbing, right? So positive, linear, and then is it a strong, weak, or moderate? Well, yeah, Aldrin, I agree. What makes you say moderate as opposed to one other?
Not strong because not everyone falls into.
It's not straight a line, right? Not everyone straight up like that.
Not weak, but it's the same with it.
But yeah, so weak is more like I can't really tell if the dots are climbing or falling. They kind of look like they're climbing, but I can't really tell that much. That's a weak. This one we can tell, right? We can tell the dots are climbing up. But like Aldrin said, they're not perfect. They're not all the dots aren't all on the same line. That would be very strong. That would be the strongest possible. Okay, so we would say there is a moderate, positive, linear association. Since they use association, we'll use association, but you could also use the words relationship or correlation. Okay. So when we're analyzing graphs, that's how we do it. Okay. So now I'm going to teach you how to do graphs. This is probably the only time you're going to have to do a graph by hand. The other times, I want you to do it on your calculator and just kind of sketch what happened. Okay. So calculator. So get your calculators. Okay. So we have a list, right? Or we actually have two lists. So go to your list. List is stat, and then you go to edit. If you have a list already there, remember clear it because we don't need that list. Okay. So to clear it, we go up to the top of the list, hit clear, and then go back down to the bottom of the list, and it's gone. So we have two lists. We have one for person weight, body weight, and we have one for backpack weight. So since X is body weight, let's put that in L1. Okay. So 120, 187, 109, 103, 131, 165, 158, and 116. Yep, there should be 8 of them, and there are 8 of them. Okay. Directly across from that in L2 is going to be that person's backpack weight. Okay. Be careful because this one you got to put in order. So the person who weighed 120 pounds, their backpack was 26. So that one has to be 26. 26 can't be anywhere else. It has to be right next to the person who's 120 because that's a person. It represents a person. 187, that was 30 pounds. 109 was 26 pounds. 103 was 24 pounds. 131 was 29 pounds. This one was 35 pounds, 31 pounds, and 28. Okay. All of our data is in there. They're both lined up. So graphs, where do we go for graphs? Second, stat plot, second button. And then you go up to y equals. We hit the second, so it's actually not going to take us to y equals. It's going to take us to stat plot. First one we'll use. So now we have graphs. We've used a bunch of them, right? We've used the histogram, we use both of the box plots. The one we haven't used, one of the ones we haven't used is the first one, the little dots. That's a scatter plot. Okay, so we're gonna hit enter. And when we do that, it gives us a couple extra options. It says, where's your X list? X list is explanatory. Y list is response. That's L2 and L1 and L2, good. And then it says your dot. Do you want your dot to be dots, like rectangles, pluses, or smaller dots? It doesn't matter. Up to you what you want. Okay, so pick one. And then when we want to see our graph, we go to zoom and then stat number 9. And there's our graph. Okay. So unless it asks you to graph by hand, sometimes they will. This is what I want to see on your paper. So how do I show that? How do I show that on a paper? Like if I'm doing an assignment, this is what I show. This is what you show. Let me see. Get another piece of paper here. So what you do is you draw your X and your Y. Okay. You still label. This is body weight. X. And then we should probably put in pounds. We didn't put that earlier. We should probably say these are in pounds. And then this is backpack weight. Also in pounds. You don't need the numbers. When you're tracing, not tracing, when you're converting, when you're just taking it from the calculator to paper, I don't need the numbers. Okay. What I do need is the path of the dots. It's one dot here, one dot here, 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 and there. Okay, so how would that look on my paper? That would look like this. That would look like this. So there's one dot down here, and they kind of go up a little bit. No, I'm missing something here. Let's see. There you go. Okay. So if you're doing it by calculator, that's what I need to see. Still labeled. Pretty much the only thing you don't need is to scale it because the calculator already scaled it. Okay. Again, I can still tell that as body weight increases, so does backpack weight. Okay. Okay. So an important kind of departure is an outlier. So we've talked about outliers before. An individual value that falls outside the overall pattern of the relationship. So let's go look at ours here. Would there be any dots that you would consider an outlier? Dots that don't fall within the pattern, overall pattern? I wouldn't say there's one. An example of one would be maybe one down here. Right? This person weighs a lot, or this compared to the other people in this group, it weighs a lot, but their backpack weighs very little, right? Or the opposite. Someone that weighs very little, but their backpack weighs a lot, right? Something that doesn't fit the overall pattern, right? I've had some people say this guy right here. What about this guy right here? Because we said he should be up, right? Yeah, but I mean, it doesn't really, it's not contrary to what we're saying, right? Maybe they weigh a lot compared to everyone else, but their backpack still weighs quite a bit. They're just not the highest, right? We feel they should be the highest, but that person really isn't outside the pattern. Someone who's outside the pattern, like we said, would be low weight, very heavy backpack, or heavy weight, very skinny backpack, very, very low weight backpack. Okay. Okay. Okay, so what type of association? Three things, remember? Form is always going to be linear. Form is always going to be linear. What's the other one? Strength, positive or negative, and then direction. Or that, no, that's direction is positive or negative. Strength is weak, moderate, or strong. So these two, the first one, gas prices at a gas station versus the number of visitors to the gas station. What do you think? If I had data, what do you think that would look like? Would it be a weak? Would it be a weak, strong, moderate? And would it be positive or negative? What do you think? So negative, so let me draw a picture real quick. Okay, so which one here? We don't have data. We're just kind of using, it's not like, it's an educated guess. We're trying to, what makes logical sense, right? So gas prices or number of visitors, which would be the X and which would be the Y? Yep. We're trying to see if gas prices affects the number of people there. Okay, so gas prices, I'm just going to put this and then number of visitors. Number of visitors. Okay. All right. So as prices are getting bigger, what do you think? What do you think would happen to the number of visitors there? We expect to go down, right? They're not going to get more people as they're raising prices. We don't expect more people to show up, right? So we would expect something in the downward trend, right? Something like that, right? Moderate or strong? Pretty strong, yeah. I can't imagine seeing a lot of people if you raise gas prices, right? Which one?
Any of them. I mean, like, I've seen a lot of chevrons. Some border cities, maybe.
Well, yeah, there's always people at like, you know, those chevrons that are always the most expensive, right? But not as many. Like if you go right here on Herndon and 99, there it used to be, that just changed. They changed, I forgot what it was, but that place is always busy because they're always like 20 cents below the lowest price. They're always like that. And they're always busy. I mean, if you pass by there at 6:30 in the morning, they've got tons of cars and they got trucks too, because it's a truck, because trucks can fill up there too, because Klein's isn't there anymore. Always there, right? And there are those places like, you know, like Chevron tends to be pretty higher in prices compared to everyone else. What about, yeah, Costco? Costco prices too, right? Costco prices tend to be on the lower side. And if you drive by Costco on 99 and what is it, the Golden State right there, that one's always crowded. It's crazy crowded there, right? Walmart gas station too, yeah. You know, but those places tend to have, like, you'll drive by some places where there's like nobody there. You look at the gas prices and you're like, oh, okay, I see why, right? So it's pretty strong, right? Moderate to strong, negative, linear relationship. Okay, good. Let's see. So let's write this down. Negative, we'll say strong, linear relationship. Okay. All right, number of daily umbrella sales versus the number of car accidents that day. So these are kind of random pairings. Yes.
So I have a question. Like, does it have to always be in that order?
No. The X and the Y you're talking about?
Yeah. Negative, strong, linear,
no, yeah, you could say a linear, usually you put linear relationship at the end, but strong and negative can be flip-flopped. That's a great question. I just need you to tell me strength, weak, moderate, strong, and direction. And then the last two are always going to be linear relationship or linear association or linear correlation. Okay. Yeah, great question. So the number of umbrella sales and versus the number of car accidents that happen in that day. So they're trying to see, I'm guessing, so umbrella sales versus number of car accidents. Oops. Let's see. Okay. So as I get more, as I sell more and more umbrellas, what do we think is going to happen to the number of car accidents out there?
Because you crash in rainy conditions and the road gets like. What do you need an umbrella for if you're in an accident? I mean, like, if it rains, you don't have an umbrella, you're gonna buy it. And if it's raining and you're driving, you got a higher chance of crashing.
So yeah, that's it. We're not even talking about the same people. These people could be buying umbrellas, and then there's different people who are having car accidents. So it's not like we're saying they have to be the same people. We're just saying as umbrella sales go up, it could be that, hey, it's raining, right? People buy umbrellas when it's raining. So, and then car accidents. Then so we could have some, it could be a week, right? A week. Oops, so it'll be this way, right? Right? I would say no correlation to a weak positive correlation, something like that, right? Could have something to do with it, or it could have nothing to do with it. Okay.
So we can write like now.
Well, here's the thing. You won't see problems like this. Most likely they'll give you the data. So it'll be easier to analyze it, right? So for this problem here, since they didn't give us the data, we can just estimate that it would either be no correlation, they don't have anything to do with each other, or maybe a weak, very weak positive. So we'll say no correlation, or weak positive linear relationship.
Well, there's too many things to think about,
All right. All right. Hey, what's up?
Are they giving more papers for the government?
No. 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 Okay, so correlation. So now we're talking about correlation. It's the same. Very, we've already kind of used correlation, but correlation has a number value. Correlation has an actual numerical value. Okay, so the correlation, they use the letter R for correlation. You know how slope, they use the letter M a lot. Y-intercept, they use the letter B. I don't know why they use R for correlation and not C, but maybe because it's got two R's in it and they just said R. I don't know why, but that's anytime we see the letter R equals, it means correlation. Okay. I don't understand why they came up with some of the symbols, but that's what it is. Okay. It measures the strength of the linear relationship. So it measures the strength and the direction. Okay. Not only the strength, but the direction between two quantitative variables. Okay. So R is always going to be between -1 and +1. So we won't have an R that's past 1 or less than -1. It'll always be from -1 to +1. So if R is positive, anything above 0 to 1, that's a positive association or correlation. Okay. So where is it? Right here. This guy right here. This guy would have a positive R value because we said it's positive, moderate. We said it was a positive, moderate linear relationship, right? Well, this one gives an actual number value to it, and I'll give you the scale in a second. If it's negative, if R is less than 0, it's going down, right? Okay. Values of R near 0 indicate very weak. So this guy right here would probably be very weak. So be R, we would expect that R to be close to 0. Okay. Strength. The strength increases as R moves away from 0 and towards the end. Extreme values of -1 and +1 only occur in a perfect linear relationship. So what do I mean by perfect linear relationship? I mean dots line up perfectly and one line goes through it. Anything positive or negative. It doesn't have to be going straight uphill. It could be kind of going like that. Or it could be going downhill. Anything that is positive or negative, like straight lines, those are 1 and -1. So these would be examples of 1. These would be examples of -1. Okay. So here's the scale here. Here is the scale and some examples of what those values look like. Okay. So in the middle is 0. I can't tell if those red dots are going up. So as I'm getting bigger on the X, I can't tell if they're going up or down. They're kind of hodgepodge. It's all over the place. So there's no relationship. There's no correlation. It's 0. But you can see as I'm getting bigger, 0.6, 0.95, they have a positive and they're becoming more of a strong line. They're getting closer and closer together, closer and closer together. Same thing with the negatives. Same thing with the negatives, okay? Because R, a -1 or a +1 would be a straight line, dots line up perfectly. And that never happens. Rarely, if ever, but I would almost positively say never, because it's real data. It's real data. Doesn't behave the way we want it to sometimes. So here is how we determine where it fits in: moderate, strong, or weak. If your R value is 0.8 to 1 on the positive side or the negative side, you notice how they have absolute value bars? It means if it's positive or negative, 0.8 to 1, we consider it strong. If it's 0.5 to 0.8, we consider it moderate, and weak, we consider anything from 0 to 0.5. Okay, so let's draw a better, and draw a number line with it. Okay, so 0 is in the middle, because this one doesn't, I don't like this one. I didn't put another one in there that I meant to do. So 0.5, -0.5. So if it falls in here, it's going to be a weak positive. Weak positive if it falls within here. If it falls within here, it's a weak negative. Okay. And then we jump up to 0.8, it says. And -0.8. So if it falls in here, I probably should have used a different color. I'm not changing the words, I'm just using colors. I'm using red for the negatives and blue for the positives. Okay, so here, negative. Here is moderate, positive. Over here is moderate, negative. And on the ends, up to 1, we don't go past positive 1.0 or negative 1.0, negative 1.0. Anything over here is a strong positive, and anything over here is a strong negative. Okay. Nothing, notice there's nothing past 1, nothing less than -1. Everything, every R has to fit somewhere on that number line. Okay. Because there's always a question every year. And the question is, if R, they say something, they talk about 2 things and they're like, R is 1.09. And then it asks you to make conclusions based off that. What kind of relationship is that? And you're like, oh, very strong positive. It's positive, so it's positive, and it's very strong because it's all the way to the end. No, the answer is can't exist. Anything above 1 is they either did their math wrong or it's just a made up number. Okay. Okay, so describe this one. Finish the sentence frame. So give me, form is always going to be linear. What's going on there? Actually, you know what? Do the next 3. Because you're doing the same thing for each. You're doing the same thing for each.
These 2?
The next 3. This is the first one.
Right.
This is the second one. That's the third one. So you're doing the same thing for each. You're describing the relation, association, describing the correlation, describing the okay, so the first one here. The last 2 we know are going to be linear relationship. I know that. Or linear association, right? Or linear correlation. But what's the strength here? Or what direction are they going? Positive. There is a positive, comma. I would say moderate. Yeah, it's pretty moderate. I would say that's pretty moderate, right? We know it's going uphill. If it's weak, we can barely tell the dots are going up, right? As I'm getting bigger, as height is increasing, so is weight. As height is increasing, so is weight. Now is it's not perfect, so it's not close to perfect, so it's not strong. I would say moderate best describes it. Okay, the next one, sprints. So years since 1990. Starts with 85, 80, 85, 90, and then the sprint times. So direction, negative. Strength, I would say that's pretty strong. That's pretty strong. Look at strong over here. Look at the example of strong over here. This guy is pretty strong, right? As compared to this guy here, right? 0.8 and higher. So 0.8 is actually closer to this guy than it is this guy. So I would say strong, linear relationship. Okay. Put that one there. So let's start with positive or negative. Okay, so here's the thing here. If this was the data right there, I would say very strong, right? Very strong. But it kind of curves up to the top, right? It kind of curves there. So strong would be pretty straight line, right? So if I had that data right there, just that data right there, that's a pretty strong negative, right? But then it kind of curls up at the end, and that throws a wrench in the line. Right? Before, it would be like this. All right, something like that. But then it kind of throws a curve in it and says, oh, now, so the linear part is not as strong. So I would actually say this is a moderate. Okay. Okay, last thing we're gonna do. We're gonna skip this for right now. We'll come back to this on Monday. So how do you find R values? How do you find R values that are right here? How do we find values that are along that line? Well, you can do it by hand. Here's the formula chart. Here's a formula here. Yeah, right. Especially on a Friday afternoon. Nope. Good news is you'll never have to use this. Okay. Do it on the calculator. So let's look at R value and let's see where it falls. We kind of said where it's going to fall, but let's look at the R value here since we already have the data in there. Okay. So we already have the data in L1 and L2. Okay, because they're going to ask you to calculate R on your assignment. And if you want to do it by hand, do that. If you don't want to do it by hand, watch me. Okay, so here we go. You already got it in L1 and L2, right? So now what we're going to do is we're going to go to stacked. We want to calculate R. So we're going to go over to calc. Now we're not going to pick one of our stats because R is not there. We're going to scroll down past the first. You see number 4 is linreg. Pass that one to the second linreg, the one that says A plus BX. A plus BX. It's number 8 on mine. Might be number 8 on yours. Might be something different. Where's your list one? Where's your X list in L1? That's my explanatory. My response is here. Calculate. Scroll down to calculate. Does anyone's calculator not have an R? Some of the calculators are missing this. I'll tell you how to fix it. So if you're not missing this, don't do it. If you're not missing this, if you see it on your calculator, don't do what I'm about to do. Okay? I'm going to show you what to do right now. I'm going to show you what to do right now so you can change it. Okay, see where it says catalog right above the 0? So you're going to go second 0. Only do this if R is not there. If you see an R, one more time. If you see an R here and R squared, don't do this because your calculator is fine. But some of the calculators need to be reset. So go to catalog, and then you're going to go down all the way till you see diagnostics on. So scroll down until you see diagnostics on. This is every function the calculator does. There's a lot of them. So go to diagnostics on, which is right there. Hit enter and enter again and do exactly what we just did. Go back to stat. I'm trying to go a little fast because we're running out of time here, but I don't want to go too fast. linreg. Now your R should be there. Okay. So our R is almost 0.8, 0.79. So where would that fall on our? So yeah, so it's on the very border of moderate to strong, right? It's on the very border. So personally, if it's that close, I would probably put strong, but you could get away with moderate since it technically is moderate. Okay. So that's how you calculate R. One last thing. I posted on Google Classroom. For those of you that don't have the calculator and you need to access this stuff at home, I posted some stuff. So last year, TI gave away free use of their Chromebook app because everyone was at home. They don't have it anymore. So you're not able to use your Chromebook. But if you have an Android phone or you have a PC computer at home, you can get it online. So I posted some videos on Google Classroom. Okay, so all you got to do is go to Google Classroom. Google Classroom, there's some videos here. The lesson videos are here. Emulator for Android phones. Emulator means it acts like a phone. So it's a program for PC computers. Okay. So if you have those, it will do exactly what the calculator in front of you will do. So you can do it at home. All right.
He's still pulling your hair.